Hello, in this video I'm going to continue talking about routing between different networks. So what you notice here, we have two routers. So this is router 1 and this is router 2. So we have router 1, router 2. These two routers have two interfaces. We have the fast Ethernet interface, which is connected to a LAN. Okay, and we have the serial interface which connects to a WAN on the other side. Same thing for R2. It has a fast Ethernet interface which connects to a LAN and a serial interface which connects to a WAN. Now we have two LANs with network address with the following network addresses: 192.168.10.0/24 and 192.168.20.0/24, and we want these two LANs to communicate through these routers. Now we have R1 connects to R2 through the WAN link, a point-to-point link, which is WAN technology, such that hosts in network 192.168.10.0/24 should be able to communicate with those hosts in network 192.168.20.0/24 and vice versa. Now we have seen that as soon as we assign IP address to fast Ethernet 00 and serial interface 000, we assign IP address and bring down these interfaces up using the command no shutdown. Automatically the routing table of router R1 will be populated with two entries. So the first entry will indicate network 192.168.10.0/24, and that this network is reachable across fast Ethernet 00, and we have another network which is 10. Here we can represent 10.0.0.0/30. So we have another network 10.0.0.0/30, and this network is reachable across serial interface 0/0/0. These two networks are directly or physically attached to R1. That's why we will see this character C, which stands for connected, in the routing table. Same story with R2. As soon as we assign IP addresses to serial 000 interface and fast Ethernet interface 00 and bring up these two interfaces using the command no shutdown, routing table of R2 will be populated with the following entries. So we have 192.168.20.0/24, and we have second entry about the WAN link, which is 10.0.0.0/30, and we notice that these two networks are physically attached to R2 using the character C. C stands for connected. So this routing table on R2 means that R2 has two physically attached segments or networks. One is a LAN and another one we know it's a LAN. It's a WAN, sorry. How do we know it's a LAN? Because it's reachable across fast Ethernet 0/0, and the other one is a WAN because it's reachable across serial interface 0/0/0. And we know that serial interfaces are always used in WAN technology. Ethernet interfaces are used for LAN because Ethernet is a LAN technology. Now, in order for R1 to forward packet sent from in this direction, let's say, any packet sent in this direction from any host on network 192.168.10.0/24 destined to network 192.168.20.0/24, R1 needs to have a static route. For example, in the case of static routing, we're going to write the following static route: IP route, destination network address, which is 192.168.20.0. We have also to mention the subnet mask, which is 255.255.255.0, and here we have to mention the next hop IP address. In this case, it will be 10.0.0.2. This is the next hop IP address through where the to where R1 is going to send the packet, which is the IP address of router R2 on the serial interface side. Once R2 will receive a packet through the serial interface, then it will be responsible for forwarding this packet until it will reach the destination, which is on network 192.168.20.0. Same thing on R2. If R2 receives a packet from network 192.168.20.0 destined to server or clients on network 192.168.10.0, we can use the following static route: IP route 192.168.10.0. Here we have to show the destination subnet mask. We know it. It is 255.255.255.0. So we have to represent it in the quad dotted decimal notation. In the dotted quad decimal notation. And the next hop IP address will be 10.0.0.1, which is this interface here. So whenever R2 receives a packet to forward to this destination, is going to simply send the packet to the IP address 10.0.0.1, and this is the IP address of the serial interface of router R1. Once R1 receives the packet, then it will be responsible for delivering the packet to destination, which is on this network. So here we have seen the static routes, and static routes you always identify it on routing table by the character S. Now the point is that if you want to use a static routes, you have to access every router and configure every route to every possible destination on the internetwork. So for example, if we have 10 different networks, you have to access router R1, or 10 different remote networks, those networks which are not physically connected to R1. Then you have to access router R1 and configure 10 different static routes. Same story, if we have, let's say, 15 remote networks with respect to R2, those networks which are not physically attached to R2, then you have to configure 15 different static routes on R2. So here there is a possibility to make a mistake, and in case you change the topology of your internetwork system, then you have to revisit every router and do the necessary changes with respect to the static routes. Now here we are going to talk about dynamic routing. In dynamic routing, what we'll do, we just configure a routing protocol. So we have many routing protocols actually. You have different routing protocols like RIP, Routing Information Protocol. You can use version 2, like what we'll do in this section. We have also OSPF. These are standard routing protocol, internal gateway protocols. We have the EIGRP, which is a Cisco proprietary protocol. We have intermediate system to intermediate system, internal gateway routing protocol, and we have also BGP. This is used between autonomous systems. Now, in our case, we are going to choose a very simple routing protocol, which is version 2. Now, what does this mean? It means that when I have a situation like this, I access router R1, and then I configure RIP version 2 on R1. Also, I configure RIP version 2 on R2. So what will be the purpose of configuring these two routing protocols? It's something like this. I will assign IP address to fast Ethernet 00 and serial interface. And then I bring up these interfaces using the command no shutdown. As soon as I enable the two interfaces, the following entries are going to appear in the routing table of R1. So we're going to see the entry 192.168.10.0/24, and then this segment is physically attached to R1 through fast Ethernet 00 interface, which is a LAN interface. And then I'm going to see the second attached network, which is 10.0.0.0/30, and this network is attached through the serial interface, and serial means one link. It's a one link or one network. And we're going to see the following. C means directly connected, as we talked about this. Same story here. I go to R2, I assign IP address to serial 000 and fast Ethernet 00. I bring up these two interfaces using the command no shutdown on each interface, at the level of each interface, and then this is what I'm going to see. I'm going to see the routing table populated. As soon as the interfaces are brought up, then the routing table will be populated with the network, with the entries that describe the physically attached segments. Let's say 192.168.20.0/24, and this segment is attached, is reachable across, or is connected to the router through the fast Ethernet 00, which means it's a LAN, because Ethernet, as we said, is a LAN technology. And then you are going to see network or routing entries, which is 10.0.0.0/30, which is connected through the serial 0/0/0. Also, this is a one link because it's connected via, it's attached to R2 via serial interface, and serial is meant for one. And you will see also these two characters on the leftmost column. These two characters C indicates directly connected or directly attached segments with these network addresses. Now, as soon as you configure the routing protocol on R2 and on R1 and R2, what will happen? You don't need, actually, here we are not doing static routing. It means we don't need to access a router, each router, and tell this R1 how to reach the remote network here, or we tell R2 how to reach this remote network. No, we don't do that. We just configure a dynamic routing protocol. In our case, we use RIP version 2, and then let this dynamic routing protocol exchange information, trigger exchange information between routers, such that each router will learn about the about a remote network which is not directly connected to it. So what will happen, let's say, to make things simple, R1 using RIP version 2 is going to advertise the following information. It will advertise to R1, hey, I know how to reach network 192.168.10.0. Okay, so this information, RIP version 2 is going to advertise this information to R2, router R2. R2 now receives this information from where? It receives it from R1. From where exactly? From which IP address? From the IP address of serial 000 interface of R1. So it is going to add entry information about this, an entry in the routing table about this information. And in this, in the routing table, you will find a new entry which contains R, which means that this information was learned through advertisement initiated by RIP routing protocol. R stands for RIP, and it contains the network address of the remote network that it just learned about it. It has learned about it, okay? And something else, it means that I learned through RIP advertisement the existence of this network 192.168.10.0/24 from where? From this IP address 10.0.0.1. This is the IP address of the serial 000 interface of R1. Same story, R2 is going to send an advertisement to R1, and this advertisement, R2 will inform R1 that it knows how to reach network 192.168.20.0/24. So like this, now R1 gets this information, learns about the existence of network 192.168.20.0 from R2, and is going to put this information in its routing table. So you will see a new entry in the routing table The letter here is R, which means that this information was learned through advertisement initiated by RIP routing protocol, and this information is 192.168.20.0/24, and R2, or let's say R1, has learned about this network address or the existence of this remote network via this or through this IP address from an advertisement sent starting from or initiated from this IP address, which is 10.0.0.2, this one here, which is the serial 0/0/0 interface of R2. So now the routing table of each router has converged in the sense that each router knows about every possible network in this intersystem. Now, I just explained RIP routing protocol, and it's a very, very simple aspect, because there are also many other things, many other information to talk about concerning RIP routing protocol. I'm going to cover this in one of my next videos, but for now I just want to describe the difference between static routing and dynamic routing. In static routing, you have to access each router and configure a route to every possible remote network. By remote network, I mean a network which is not physically attached to that router. Whereas when using dynamic routing, just go to the router, you configure this dynamic routing protocol, and then let this routing protocol trigger exchange of information between routers like this. Each router is going to inform the other routers or the neighboring routers about the networks that it knows about, and those routers are going to get information and then put it in their routing table, but they will always say that I learned this information, the source of their information. For example, here R1 is telling to us that the source of information from where it learned about the existence of this network address about remote network is 10.0.0.2, which is R2, and also R2 here is telling us that I learned about the existence of network 192.168.10.0 from IP address 10.0.0.1. It means that it is R1 who told me about this, and for R1 it is R2 who told me about the existence of this network. What does this mean? It means that next time, if R1 has a packet to send to this destination network, it will simply forward it to this IP address 10.0.0.2. It is normal because it is from this IP address that it learns about the existence of this network. So just send the packet to the source of your knowledge or information about the existence of this network ID. Same story here. If R2 has a packet to be sent to this destination network address, just forward it to this IP address. Exactly, this is the point, or this is the IP address from where you learned about the existence of this network address. Now, in the next video, just right after that, I'm going to give a demo about how to configure RIP routing protocol version 2.